Hi everyone, how's everything going? This is Jay, sir. This is another episode of me digging into the React source code. It's episode 24. Today it's about Act. I don't think many people have used this before because it's a testing utility function. Actually, React has provided quite a few testing util functions like Act, mock component. Honestly, I have never used one of them because I think we're not supposed to, because this is our kind of low-level API for testing, and we're usually using them not directly but indirectly from other testing libraries, and like a React testing library or Jest. A Jest is it's not about the framework. It's a test runner, so not Jest, but React test library that wraps up this stuff. But today, I'm very interested in how Act worked. Because I remember when we were writing the testing code for React, we kind of like needs to wrap our functions into the Act to get the effects, get them run. So this Act is pretty important, and I'm curious about how it works. So let's first start with the demo. Okay, before, yeah. So what does the Act do? There's an official documenting says when writing UI tasks like rendering, user event, or data fetching can be considered as units of interactions, and Act can make sure that all updates related to this unit have been processed and applied to DOM before you make any assertions. It's quite long, right? So basically, simply put that everything wrapped in the Act, and the task there will be flushed synchronously. Remember, synchronous means the React internals. It doesn't mean that if, say, okay, when I start requesting some data, this will wait for the data. No, it's not. But if you return promise, it will wait. But generally, it will only make sure that React will react to your interaction into your with your callbacks synchronously. So here's a demo. Let's open it. The code is simple. We have an app, and this is the effect run every time, and it will log the effect, and we render the app, and then we console log the after render. So let's see what will be logged in the console. Oh, sorry. Cool. Reload, after render, effect. After effect, after render, effect. Why? Because we're already familiar that use effect, the things in use effect will be run after the DOM mutation is done, right? So it's asynchronous. It's not synchronous, it's asynchronous. So after render will be run before effect. That's pretty straightforward. Now let's wrap the render recdom here, root render this into Act. This is unstable Act. It's the what we get from the React development build. Basically, this is because I'm testing it into the UMD module. In real, you should use the Act by importing them. Cool. And now let's see what happens. This is another demo. Let's open it and console log. It's called effect first and then after render. So this is kind of against what we know about React, right? You say, okay, this suddenly becomes not asynchronous anymore. But generally for React, what's the best about React is that it makes things declarative, and so for user side, we should not worry about the timing about each piece of code, like effect, those hooks. As we said, as I mentioned in the previous video, that these timings can be sometimes hoisted by layout effects, stuff like that. So we should not worry about them. But why we need this is that asynchronous sometimes makes things unstable. You need to wait for some time, right? And the code needs to be asynchronous. It's pretty like a console log here. If we're going to do some assertions versus the real DOM, it's gonna be the pain in its ass. You'd like, okay, I need to do asynchronous. This function, testing function will be asynchronous. I need to await, or I need to just keep monitoring, polling the DOM element and do something like that. But wrapping all of them into a synchronous way will make things easier because it's just less hassle, and it possibly will save us some time. It might accumulate to a huge benefit, like every test, like save us several milliseconds. But for a large project, it might be hundreds of tasks, right? That's just to save a lot of time. Cool. So this is it. This is basically how what we expect from the Act. It makes asynchronous stuff rendering inside of React internals to be asynchronous. So how does it work? Well, it's simple. Not simple. It's interesting. I have two other episodes explaining things related. The first thing is about how effect hook works, the life cycle. So this is pretty long, so I just skip it. So if there anything here, where is it? Okay, it doesn't say much, but let's focus on the piece of code here. Here. So when we define passive effect, which basically means use effect, they are flushed into the commit phase. I've mentioned this quite a few times. The rendering, the whole update of the React is divided, I think, into basically two phases. The first thing is rendering. When rendering, just reconciliation, meaning we have a fiber tree with the internal representation of the DOM, and then we need to create a different tree. And when we create it, we would, while we are creating the new version of tree, we could reuse the old fiber nodes, or we create a new one. And while we are doing that, we mark some of the fiber nodes that which needs the DOM modification, whether it's removal or update the properties or create a new DOM node, something like that. And after that is done, we would commit to the DOM, which means reflect those changes necessary to the DOM. So that's in the commit route. This is the commit route is synchronous, and inside of it, actually there's a piece of code where checking whether we have some passive effects that need to be run. So basically here you can see, okay, for the code like what we're doing here, we have the use effect. So where we run, which committed them, we will see, okay, we have some passive effect, we need to do it. So what it does is that we schedule a callback, and you can see that it's flushed the passive effects and do nothing. Just a normal scheduler party. You can take a look at how scheduler works. There's a different post on my blog explaining that. So basically, what you can think of is that this schedule back will schedule this function asynchronously by trying to use the best built-in function as we can, which could be set immediately, or using the message channel, like this is a trick, or if this both two are not supported, we use the set timeout. So timeout is pretty easy to understand, right? Just defer them in the next frame. So yeah, remember, this is very important. It means that while we are re-rendering, after we re-rendered the whole thing, commit to the DOM, we would schedule the callback in the next frame to flush the passive effects, which is the effects we're having here. So they are asynchronous. But in Act, if we open the code here, we can see that it's something interesting. The first is that this is the callback. Callback is this render. So actually there's a picture here, I guess. Yeah, this is the render. When we're wrapping in the Act, this callback, we run it, it will be run, and it will have some checks about the async promise stuff, but let's skip that. And there is a function called flush act queue. So there is something called queue. This is important. In the flash queue, In the Flash queue, you can see that there is a for loop. It will try to run the callback for all the callback, and it will be done. And the React current act queue, yeah, it's a queue. You can think of it like an array. And so when it is run is act callback is called, callback is called. And then because the callback is the render, it will internally call the schedule put callback here. Yeah, and to ensure root is scheduled, it will call the performance concurrent root work on root, which is why we here it's the new version in concurrent mode. It's the root render. It's not React DOM render something on DOM elements anymore. Yeah, it will call that, and it will be scheduled. And as we said, after this the queue is inserted, it will start flashing it, and it will run this callback, and then somehow again another thing callback is scheduled in the queue. And the flush async, as we already see, while we are processing the callback, this queue grows, but this for loop will continue working on that, and then eventually all the tasks will be cleared. And because performance concurrent work on root will result in the committing phase, right? When they commit, it will schedule a flush passive effect, and this schedule somehow will result the task into this React current act queue again. So this process is pretty straightforward, but there is a one piece of puzzle that we are not solving, which is how this queue is in-queued and processed, right? We've already seen how they process actually, flush act queue. We only want to know how it is in-queued. So here's the trick. Not trick. This is the picture indicating the callback, the call stack of the render. Inside of it is update container and a schedule update on Fiber. And this one, we're already familiar with it. It's just schedule update in the task. And inside of it, it's called schedule callback, which is interesting, which leads out to this piece of function, where we could see the whole magic of how act work. You can see that this schedule fallback, if check if it is dev, if it is not, because act only works on a dev end for testing, so it's not in the production build. There's no meaning that we expose that. So under dev, it will check that if the act queue is not now. It means that if it is not, it means that if it is not now, it means that the act function is called, so it will push the task into the queue. Otherwise, it will feed it to the scheduler. Scheduler, as we said, it's asynchronous. So now the trick, and we already see how the trick works, right? When the act is called, like here, we can see that it actually will initialize the act queue as the first step. Default is null, and it will initialize it to an empty array. So while we are checking here, if act is not called, this will be null. So everything works as before. Now it becomes an empty array. It's not now anymore, so it will push the callback into the queue. Yeah, if the queue is there, the callback is pushed to the queue. Otherwise, this goes to the scheduler. And after perform concurrent root in the committee phase, we find that there are passive effects to be flushed. Yeah, and it calls schedule callback again. So as we said, the queue keeps growing while we're processing, and eventually all of them will be flushed. So this is it. This is how act works. It actually creates a new, it doesn't interfere with the internals of scheduler itself. Rather than messing up with the scheduler, it creates a new task queue, right, beside of it, and it will create another branch of handling the code while we are triggering them, which is through the stiff difference in schedule callback. Cool. So inside of the React runtime, it's interesting that how these Act queue is imported. Actually, it's imported from the React shared internals, and that one is exposed into the global React called secret internals do not use or you will be fired. Yeah, I guess Facebook could fire anyone in the world, even though they're not in their they're working in Facebook, right? Okay, cool. Anyway, it's actually a alias to this React shared internals, and the React and shared internals in a different module, and it will set up the React concurrent apps queue if it is under dev. So all the part here is actually guarded by dev. It will be stripped into the production build. So in production, even though you can see that this one is there, but you cannot access the React concurrent current act queue. I don't know why they're doing this, because we can import in it and obviously do the stripping as we want. But I think there's some legacy reasons. If you know more, please comment on this post or comment on my video. Cool. Let's summarize it. So, when act is called, a shared callback queue called React current act queue is initialized, and in the React runtime. And if this queue is not empty, the callback scheduled will be pushed into this queue rather than go feeding to the scheduler. In scheduler, it will be asynchronous, but in this queue, it will be processed synchronously. So in act, React concurrent queue is processed and flushed until it becomes empty, all done synchronously. This answers why effects are flushed synchronously in under act, since the task scheduled to flush this one, flush all the past effects are going to the queue. React scheduler is bypassed. It will not go to the asynchronous, but go to the synchronous one. Cool. This is it. It's quite fun, right? As this is the 24th video of me doing the React internals, I become more and more confident about how React works. There are a lot of puzzles that needs more effort to figure it out, but I'm very happy that I can explain some puzzles rather than just fiddling around with the debugger at what I did in the first episode. It's pretty messy, but anyway, that's it. I hope this episode could give you more understanding about React. Also, if it could, I hope that it somehow ignite the inner fire in yourself that drives you to digging into the React internals. That's just a continuous journey together. Welcome to my Discord server. There are quite a few people right now. Yeah, this is it. Hope it helps. See you next time. Bye bye.